Hello everyone, I'm going to explain the error detection and correction. Error detection and correction topic in the data communications and networking. So first of all, I'm going to explain the basic concepts. So what are the different types of errors and how we are going to detect the errors and all those things. Okay, and first of all, whatever the topics I'm going to cover is types of errors, the redundancy, error detection. So at the end of the topic, you are going to know about the different types of errors in a message. As a basic computer networks, we know that how the message is sent from a sender to the receiver. So sender will send a message to the receiver, and in the middle this error may be changed. So the error may be corrected in the middle before received by the receiver. So here I'm explaining different types of errors. So data can be corrected during the transmission. Some applications are required to correct the errors. And types of errors in a single bit error. So in a single bit error, only one bit in the data unit has changed. So here we have an example. So this is the original data sent by the sender. Whenever it is received by the receiver, the bit in the fifth position, that is 0, is changed to 1 when it is received by the receiver. In the entire data, only one bit is changed. So this is called a single bit error. And next, burst error. Burst error means two or more bits in the data unit have changed. We'll see one example. So this is the message sent by the sender, and whenever it is received by the receiver, multiple bits are changed here. So this bit in this position, that 0, is changed as 1 at the receiver side. Again 0 to 1, and this 0 is also changed as 1 here also. These are called as the corrupted bits, and the length of this is called as the length of burst error. And to detect or correct the errors, we need to add some extra bits. That extra bits are called as a redundant bits or a redundancy data. So these redundancy bits are added like this. So here we have a sender. Sender will encode the message by adding some extra bits that we call as the redundancy bits. And the receiver, whenever receiver receives a message, he will check the errors. After checking the errors, if there are no errors, then it decodes a message. And at the sender side, first we have a message. So by using this message, this generator generates the redundancy bits and adds these redundancy bits to the message. Message and redundancy bits, we can call it as a code word. Then this code word is sent to the receiver. Receiver receives the original message along with the redundancy bits and checks for any errors. Okay, if there are any errors, simply it discards the message. Otherwise, the message is received by the receiver and the receiver can read the message. The error detection. So here the enough redundancy is added to detect an error, and the receiver knows an error occurred but does not know which bit is in error. So less overhead than error correction. An error detecting code can detect only the types of errors for which it is designed. Other types of errors may remain undetected. So this is a process of error detection in block coding. Sender sends a k bits of data word. This is the original message, and there is a generator which generates a code word. Code word is the combination of the data word and the redundancy bits. So it is of n bits. This n bits of code word is sent to the receiver. And this at the receiver side, this code word is given to the checker. Checker will check for the errors. If there are any errors in the code word, simply it is discarded by the receiver. If there are no errors, the receiver extracts the original message from the code word, that is the k bits of the original message, and it reads that message.